Hey everyone, it's Miss Lloyd again. We're looking at circular functions today. So still checking out trigonometry. And so when we're talking about arc length, we're talking about part of a circle. So here's our circle. And so our S, so say I have standard position. So starting on our positive, what would be our x-axis? And then I have this arc length here that goes to a certain angle. And then we're stopped off at this point here, P point XY. And so this here is our S for our arc length. That's not a 5. It's an S. So S, that arc length in the unit circle, is in standard position. And if we have a point XY, that is the end point of that arc, then sine of S is equal to Y and cosine of S is equal to X, something that we've already kind of talked about. So then our four ratios in terms of sine and cosine. So we've said that cosine is x, sine is y. So if we're looking at tangent, this is going to be equal to, it's always what? Tangent is opposite over adjacent, so we're using sine or y over x. So sine of s over cosine s. And then secant is the reciprocal of cosine. So it's just 1 over cosine s. And so these are both only if cosine of s is not equal to 0. Because on the bottom, if cosine of s is equal to 0, then it would end up being undefined. So then we also have cotangent, which is just the reciprocal of tangent. And so it would be the reciprocal, so we flip it, cosine over the sine of our s. And then the inverse of sine is cosecant, so CSC. And so we would just have 1 over sine of whatever that arc length is. And then again, this is if sine is not equal to 0. Otherwise, it would be undefined. So then this next part, so for some number s, at the point we have negative 3/5 comma 4/5. Is s units from a 1 comma 0 along the unit circle. We want to find the exact values of the 6 circular functions of s. So I'm a very visual person. I'm going to draw this out a bit. So 1 comma 0 is going to be there on the unit circle. So I'm just going to the right one and I'm not going up or down. And then if I'm looking at the point negative 3/5 comma 4/5, that's going to be in the second quadrant. So maybe somewhere over here. I know that second quadrant area. So that's my P. So then if I'm doing my sine of whatever S is, it's just the Y value. So 4/5. Cosine of my S is just my X value, so negative 3/5. Whenever it comes to tangent of my S, I'm doing my sine, so 4/5 divided by my cosine, 3/5. And so what I would do, same change flip, and I would end up with negative 4/3. And it wants all 6, so then I'm also doing the cosecant, so CSC of S. And I'm just going to flip my sign, so 5/4 is the reciprocal. Same with the secant. I'm just doing the reciprocal of my cosine, so it's -5/3. And then the very last bit, my cotangent of s, I'm doing the reciprocal of tangent, so I just flip my tangent, so -3/4. And then we're done. Ta-da! And so next, we want to find the sine, cosine, tangent of each of the following to 4 decimal places. We can use a calculator. It says or table 6, but like again, we don't really use table 6 anymore because we have calculators. In this, we also want to set your calculator to radians because these aren't in degrees. So notice there's no degree symbol. So these are going to be radians. So you want to go to mode and then arrow down until you see degrees and radians, and you want to make sure that you're setting it to radians. So radians should be highlighted. So we definitely need to be set to radians in order for this to work. So then whenever they talk about, okay, we're doing the sine, cosine, tangent, so then we can just plug into our calculator sine. So it'd be just the SIN button of 2.94. You'll hit enter and it wants us to do 4 decimal places. So that should end up being 0.2002. And do this in a fun color. There we go. And then we'll plug in cosine. Same thing. Again, you want to make sure you're in radians. This is -0.9797. And then we have tangent, 2.94. It's going to be equal to -0.2044. And so go ahead and check out the next one. You're doing the exact same thing. So just doing sine, cosine, tangent of this -0.14. And then I'm going to do kind of a fast lap through it. And here you have it, all of our solutions when we plug this in. And so if you're not entirely sure like why this works the way it does, you can always change these from radians to decimal or to degrees so that you can kind of better understand. So this, because it's -0.14, this is in the 4th quadrant because it's a very small radian. So this is in the 4th quadrant. So in the 4th quadrant, our cosine would be positive, our sine and tangent would be negative. And so over here, the 2.94 would end up being in the 2nd quadrant. So you can do that conversion if you like. So our sine would be positive and our cosine and tangent would be negative. But we shouldn't get used to, I mean, you can do it now so that you can, like the more conversions you do, the more you understand like what they are in relation to each other. But it's not something you want to rely on. All right, so the next one we're going to find the exact trig values for these. So if the function is undefined, we've got to say so. So then here I have -pi/3. I know pi/3 is same as 60 degrees. So that's our reference angle. That's our in degrees. So that's what my ring finger, if I'm using the trig hand trick. And because it's negative, this is in the 4th quadrant. So again, we don't want to get used to converting every single time from radians to degrees, but it just may be helpful for this first bit so that you can get that understanding of how much pi/3 radians is. So then going through the sine, cosine, tangent, cosecant, secant, cotangent. So if I'm doing sine first, I'm putting down 60-degree finger, so my ring finger. And I know in the 4th quadrant, sine is negative. So then I'm looking to the right of my bent finger, so that's √3/2. And because we're in the 4th quadrant, sine is going to be negative. And then cosine, -pi/3, still doing that bent finger, so we end up with 1/2. And quadrant 4, cosine is positive, so I'm going to leave it positive 1/2. Tangent, -pi/3. So I'm putting the right side of my hand on top of my bent finger. This is how I flip my hand. You don't necessarily have to flip your hand. So this would end up being -√3. So I would have 3 fingers on top, 1 finger on bottom. So square root 3 over square root 1, which is square root 3. And I know tangent is negative in the fourth quadrant. So now I'm just going to do all the reciprocals. So then I have cosecant, negative pi over 3. And so what I would end up doing, negative 2 over square root 3. And then when I rationalize it, we would have negative 2 square root 3 over 3. And then I have secant for negative pi over 3, and that's reciprocal of cosine. So 1/2 would just be 2. And then my cotangent of negative pi over 3 would be equal to negative 1 over square root 3, which we can rationalize it to negative square root 3 over 3. And we're done. So then next part here, we're doing pretty much the same thing. So I can change this into degrees if I want to. So it would end up being 225 degrees. What I could also know is that this is a 45-degree reference angle, or pi over 4 reference. And then the important part is 5 pi over 4, so that's a little bit over a full pi. So instead of 4 over 4, 5 over 4. So I know this is going to be a little bit past pi, which is 180. So this is going to be in quadrant 3. So past my 180, past my pi. So then now I'm going to go through and do the same thing. So we're doing our 45-degree reference finger. So your middle finger is what you're putting down if you're using the trig hand trick. And then I'm going to speed through this a little bit, but you can still check your work. And there you have it. So quadrant 3, sine and cosine are negative, so it will be their reciprocals, and tangent is the only thing that's positive. So cotangent will also be positive in quadrant 3. And then we're ready for the next bit. So here are a few more. So again, I want you to kind of figure out what those reference angles are. For this first one, it's a little bit different. We have over 2. So this means that it can either be a 90-degree reference or a 270-degree reference. So then, but I know that I can take out, 4 out of the 2? So that would have been, 2 revolutions, or a full revolution that's in there. So this is technically, 450 degrees, which if I take out 360 degrees will end up giving me a reference, of 90 degrees. So you could also say we take out an entire 360 degrees by taking out 4 from the top. So taking out an entire 2 pi, and we would be left with just pi over 2. So then pi over 2 reference. And so here, because it's the 90 degrees, I'm putting down my pinky. So then whenever I'm doing my sine of 5 pi over 2, sine is to the right, and so I have 4 fingers to the right, so then that's going to end up just being 1. So again, if it's pi over 2, hey boo, what's your sign? It must be pi over 2, because you're the 1. So yeah, sorry, I'm going to scar so many people for life with that. And so here we would end up, there's nothing to the left of my pinky, so we would have 0 for cosine. Tangent, remember, is sine over cosine. So because my cosine is 0, I would have 1 over 0, which would mean that we're undefined. And then I'm doing all of the reciprocals here, so then my cosecant of my 5 pi over 2 would just be 1. And then my secant, 5 pi over 2, I'm flipping 0, so I could say 0 over 1. And because I'm flipping that, I would have a 0 on the bottom, so this is undefined. And then the last one, cotangent, 5 pi over 2. Instead of 1 over 0, I would have 0 over 1, which is just 0. So just because tangent is undefined doesn't mean cosine is, or cotangent is also going to be undefined. And then our last one here, so you can go back and forth. So my reference here, or my actual in degrees, I would have negative 210 degrees. So this is a reference of 30 degrees. And then this would be what? Since I'm doing negative, normally it would be in the third quadrant, but because I'm going clockwise, it's going to end up in quadrant 2. So a bit past negative 180 going clockwise. And so because this ends in a 6 down here, I know this is a pi over 6 reference. So then my pi over 6 or my 30-degree finger is my pointer finger, so I'm going to put that finger down. So my sine of negative 7 pi over 6 is going to be 1/2, since I'm looking at the right side of my finger. And because I'm in quadrant 2, that's going to remain positive. And then cosine negative 7 pi over 6, that looks disgusting, we're going to get over it, would be square root 3 over 2, and because I'm in the second quadrant, that would be negative. Tangent of negative 7 pi over 6. I'm flipping my hand, so I would end up with 1 over square root 3, which is 3 square root 3 over 3. Because it's tangent, it's going to be negative. And then we're doing the reciprocals. And then we're done. So then our very last one that we're going to look at, they give us a decimal, so because they give me this decimal, I know I'm going to need to use my calculator. And so we're trying to find the cosine of x. And notice here that this has a pi over 2. So in your calculator, you want to make sure you're in radian mode, or this isn't going to work out for you. So we want radian mode. So then here, in order to get rid of the cosine, I'm going to do the inverse cosine. So the cosine to the negative first, arc cosine. So x is equal to, I'm plugging into my calculator, cosine negative 1 of 0.5234. And so this is automatically going to give me whatever's in the first quadrant, and that's what we're looking at here, since we're in between 0 and pi over 2, which is 90 degrees, so this is first quadrant, and that's what your calculator gives you to begin with. Unless it was negative, then it would give you the second quadrant, because cosine is negative in the second quadrant. It'll give you the closest to your 0-degree mark. All right, so plugging that in, we should end up with 1.02. And that's it. So my students, you can find your homework assignment on LMS. And the rest of you, you can leave a message if you have any questions, like, subscribe, share, all of those great things to see more videos like this with my rambling and my terrible pickup lines. So see you later.